Hi all. This time I wanted to quickly talk about Bruin's Python asset capability. So we're looking at a simple Python asset. A Python asset for Bruin is just a regular Python script that runs on your machine that you can just put a few lines of comments at the top. You can give it a name if you want, you can give it a description, and that would be pretty much it as the bare minimum. And this asset, you can see, imports a package and then prints hello world. When I click run, we're going to see that Bruin starts running the asset and runs it basically. Now you have a request import and it worked automatically. How does that work? Bruin walks through the file tree and tries to find the closest requirements.txt file to this asset itself, which in this example we're looking at a requirements.txt that lives in the parent folder of this asset, and it contains the requests as a dependency. Yeah. So here, the moment that you hit run, the moment that you run an asset, Bruin finds this file, creates a virtual environment with this dependency, installs the dependencies, and then runs your asset in that virtual environment. Now, let's take a look at another example. Let's see if there is alter in this environment. No, it says no module name alter. I'll go ahead and add alter to our requirements.txt, and then I'm gonna hit run here. As you can see, the moment that I added alter here, when I imported alter this time, it worked just fine because it installed alter already in a virtual environment. The first time it sees a dependency, it might take a little bit more, but after that, it's always going to be instantaneous. Now, another cool thing you can do here is if you are using the cloud environment, you can mix and match different Python versions and different assets. So you can say, yeah, I want to run this asset with Python 3.10, and also you can do things like, I want to run this asset in a larger instance. Let's say I will have a heavy machine learning model. I need more CPUs, more RAM. I can simply pick a larger instance type and the cloud environment will automatically respect that. Now, another cool thing that we do here is secrets management. Okay, so secrets management means you can have different structured and unstructured credentials that will be automatically injected as environment variables into your scripts. What do I mean by that? So let's take a look at an example. So I wanted to inject GCP credentials from my account into here. Let's print the values from get env GCP credentials. Yes. When I run this, I will see that automatically the credentials are injected as a JSON string into the environment variables for those that are structured larger objects. Here you have all the details about the project ID as well as the service account JSON here. Let's say I wanted to get the Metabase username instead, which is another credential here. When I click run, it automatically brought in the value for the Metabase username, which in this example is Burak. You can also change environments and run these scripts, run these assets against different environments. And when I run it against staging, you can see that without changing anything in the code, I get a different username value, a different credential, because in that environment we have a different username and password defined. So this is a quick example of what Bruin can do. You can also always define different dependencies. You can define different sets of dependencies here that would automatically make this asset a part of the pipeline with dependencies as well. Or you can simply say, I want to run this in parallel automatically as soon as the pipeline starts, and it will automatically run that. That would be it. So long story short, Bruin takes care of environment management for you. Bruin takes care of provisioning different images and instance sizes on its cloud environment, and it takes care of secret management and the secret environment management so that it injects things automatically. Hope this was helpful. Hope we can see each other next time.